yesterday we were discussing the adjustment factor. We did one example for the adjustment factor of the work zone. Then we looked at how to calculate the free flow speeds, okay, for freeways and multi and highways. And then the next step is you have to decide what type of analysis you want to do. And we have these three options, okay. You can find out level of service, you can find out service flow rate, or you can find out number of lanes with the design. Okay, in all these cases the common factor is heavy vehicle adjustment factor. Okay, so we need it in all types of analysis. So we need two things here. This one is the percentage of heavy vehicles, and this one is the effect of heavy vehicles, equivalency factor or effect, whatever you want to call it. And this effect depends upon the terrain. Okay, so we have two main terrain conditions, okay, gradient or general. If you fulfill one of these conditions, you have gradient. If you don't, you have general. If you are falling here, then you can either have rolling or level. For rolling, the gradient should be more than 2%. So if you are on this side with more than 2% gradient, you have rolling. Otherwise, you have level. In both the cases, we have one table, which is this one. Okay, so if you are on the general side, general terrain, you just need one of these values. Okay, if you are on the other side, the gradient, then we have two more tables. Okay, but before we go into those tables, we need to discuss the two types of heavy vehicles. Okay, heavy vehicles have more than how many tires? 4. Okay, more than 4 tires is a heavy vehicle. Okay, within that we have single unit trucks and trailer trucks. Okay, single unit trucks are those with 6 wheels. Okay, so you see the trucks which are carrying furniture, normally use it for house shifting, or those who are delivering goods from stores. Okay, so those are single unit trucks with 6 wheels. Okay, fire trucks are normally single unit trucks, big ambulances are single unit trucks. And then you see, if you go to the port side or to the causeway, you will see bigger trucks, those who are carrying number of cars, or those who are carrying containers. Okay, those are trailer trucks. Okay, so 6 wheels and more than 6 wheels. Normally, smaller ones are more. Single units are more, trailer are less. This is the normal case. Okay, so if you have a gradient with a normal case, then you will use this table to find out the equivalency factor, EHV. Okay, what are we putting here? I need gradient, I need the length of the gradient, and I need the percentage of heavy vehicles. Okay, clear? So if you have a gradient, you need these three things to find out the EHV. Okay, this is for normal case. Normal case means what is more? Small ones are more. Okay, but SUT means what? Single unit truck. Single unit truck. Okay, I know you guys are playing this game now. This is in every section. P means this, S means this. Coming out with your own words. Single unit truck. Okay, so this is a normal case. Single unit trucks are more. Okay, but single unit trucks can be equal to trailers, or they can be less than trailers. If you have any of these conditions, then you will use this table. So this table is for the rest of the conditions. If they are equal, or the trailers are more. So half of the table, this half, is when trailers are more, and this half when they are equal. Okay, clear? And again you need the same things: gradient, length of gradient, and percentage of heavy vehicles. Clear? Okay, so what are we trying to do? I'm trying to calculate FHV. For FHV I need EHV. EHV has 3 tables. This one for general terrain, level or road. This one for gradient when single unit trucks are more. This one for gradient for other cases. Okay? Clear? So you must know the terrain, and if you are in the gradient, then you must know which case you have, more or less or equal. Okay? We have an example. A freeway is in a rolling terrain. Traffic has 12% trucks, 3% RVs. RVs mean recreational vehicles. Recreational vehicles. Okay? In the new code, they are merged with the heavy vehicles. Okay? So 12% trucks and 3% RVs are the same. Total 15. Okay, heavy vehicles total 15%. And then the volume is given 3,200 vehicles per hour. Now they are asking for volume in passenger cars per hour. They gave us in vehicles per hour. They are saying find out in passenger cars per hour. Okay, there are 2 ways to do it. There are 2 ways to convert the volume into passenger cars per hour. Okay, the first one is using FHV. Using FHV. This is the equation for FHV. Okay. How much was the percentage? 15%. Okay. EHV depends upon terrain. They did not give us the gradient, they gave us directly it's rolling terrain. So I don't need to decide anything. Okay. Rolling terrain. Rolling terrain. Okay. So 3. Okay. So how much is FHV factor now? Okay. Now, what can we do with it? If you want volume in passenger cars, just divide the volume with FHV. Okay, this will convert it into passenger cars. How much? Okay, clear? This is one way of doing it. We used what? FHV, direct. Okay. Another way is use EHV. Don't calculate FHV, use EHV. But to use this, I need number of heavy vehicles. I have 15% heavy vehicles out of 3,200. So what's the number? 480. Now these are heavy vehicles, right? These are heavy vehicles. So each heavy vehicle has an effect of how much? 3. EHV is the effect, right? So every heavy vehicle has an effect of 3. So 480. How much? Okay, so I had 480 heavy vehicles, I converted them into passenger cars. 480 heavy vehicles equals to 1440 passenger cars. These are 15% of the total, right? This is 15% of the total. The remaining is what? Passenger cars, already, don't need to convert, right? So I just add them now. So I have 1440 converted plus the existing one, which is 15% were heavy, so 85% remaining passenger cars. How much? 416. Okay, the values are very close to each other. Okay, if there's no rounding off, they would be almost equal. Okay, just this much error is because of rounding off. Okay, clear? Any questions? Okay. Yeah. In the previous question, they said rolling terrain. I didn't have any problem. But it can happen that they may not say any type of terrain. They may give me the gradient, and I have to decide what type of terrain. Okay. And those cases, it may happen I may have more than one gradient, like in this example. Okay, I have two values, 3%, 5%. Okay, so, and it can happen on the highway. It's very common that the gradient changes. Okay, it's very common, nothing unusual. So what can we do? Okay, I can decide about this one, what type of gradient I have, what type of terrain I have, do the analysis, calculate FHV and everything. And I can do again one more time for this one. Okay, if there are 3 gradients, then I will do it 3 times and 4 times and so on. Clear? This is one way of doing it. Another way is you calculate average gradient. For 2 or 3 or whatever number of values we have, we combine them into an average. Okay. Now how do we calculate the average gradient? Gradient equals to, gradient is the ratio, right? Slope is the ratio. What upon what? Height upon distance. Okay. So average gradient is total height upon total distance. Total height upon total distance. Total distance, you can see it. We have 3000 and 5000, right? Okay. So total is their sum. Total height. They gave me the gradient, right? I have 3% gradient. So if you know the gradient, then height equals to what? What? By 3000. Okay, gradient into distance. Same thing with the other one. Okay, so total height upon total distance. How much now? Okay, so don't need to do it for 3 and 5, we just do it for 4.25. Clear? Okay. Now, if I have this one, this thing, then let us see if I have general terrain or gradient. My gradient is what? More than 5, more than 3 or less than 3? More than 3, so I am here. More than 3, the length should be more than 0.25 miles. How much was my length? Total length is 8000. Total length is how much? 8000. In miles, how much? More than 0.25. 1 mile equals to how many feet? We don't know, but it's more than 0.25. Huh? 1 mile equals to 5000 something feet. You have 8000 feet. Okay, your length was 8000 feet. 1 mile has 5000 feet or something. So 8000 means more than 1 mile. 8000 feet means more than 1 mile. Okay, so my length is more than, obviously, more than 0.25 miles. Clear or not? Okay, so I am here. I fulfill this condition, so I have what? Gradient. Okay, clear? Now, after you know this, then depending upon how many single unit trucks you have and trailer trucks you have, you can either see the value from this table or this one. Clear? But you are looking for now 4.25%, and the length is total 8,000 or whatever miles you have. Clear? Okay. Any questions? We can double it, yes. Okay. Some more examples given. You can try them. Okay. So instead of look at part A. Instead of 2 gradients, now we have 3. This one, and this one. 3%, 2%, 4%. Okay. So for calculating total height, now you will use 3 gradients, and calculating total length, you will add these 3 lengths. Okay. The procedure is the same. Clear? Any questions? Clear? You don't see any negative value here. There is no negative value, but it can happen. Gradient can be negative. Okay. If gradient is negative, we just put a minus sign to the gradient. Okay. If gradient is negative, any of the gradient is negative. So for example, if 3% was negative, I will put minus 0.03. Clear? Negative means down. Okay. Clear? Now if you put negative value or a negative gradient is given, but the table also has positive values, what do I do here? We will take a positive? Yeah, don't believe me. Yes. Yeah, it has a row for negative values, which is the first row. First row says what? Equal to 0 or less than 0. Negative is less than 0. Clear? Any questions? Okay. Now we will do a series of problems now. Okay, all equations and everything is done. We will do a series of problems. Every problem is different from the other. Okay. So if you understand one but you don't understand the other, don't assume that they are same. I'll see it later. No, they are not same. Okay, each problem is different. If you understand one, you don't understand the other, then you will not understand by looking at the first one. Okay, so if you have problem, raise questions. Okay, raise question about the problem. Don't create problems. Okay. So we have a freeway, 4 lanes, 10 feet lane width, lateral obstruction 0 feet from the road. So lateral clearance is 0. Okay, you have the road and the obstruction. Ram density 5, rolling terrain, 2% rocks, 0.95 peak hour factor. Volume in the peak hour is 3000 vehicles per hour. They are asking for level of service. Okay, this is called operational analysis. We have 3 types, right? This is the first one, operational analysis, finding out level of service. Okay, whenever you have this type of problem, the first step is common. This type of problem or any type of problem. Okay, whenever you have anything related to level of service, operational analysis or service fluid analysis or design analysis, in all these types of problems, common factor is free flow speed. In all of them you need free flow speed. Okay, in some of the problems they were given, it was given, free flow speed was given. Is it given? No. Other option is we can measure it. Okay, but then we have to go to US, right? Anybody wants to go there? Everybody, but we will not. Okay, so we cannot measure it, so we will calculate it, but you must have free flow speed. Assume it, sorry, not assume, it should be given, measured or calculated. Okay, not given, not measured, we will calculate it, but you need free flow speed. You need free flow speed. Okay, free flow speed for freeways, this is the equation. Okay, the things which are given in the question, they gave me ram density 5, They told me lane width 10 feet. They told me lateral clearance 0 feet. Okay, so TRD you will just put it as it is. Okay, lane width, we need the factor. We have a table here, lane width 10 feet, so factor is 6.6. Then factor for lateral clearance. Lateral clearance is 0. So the last row. Okay, how many lanes? It was 4 lane freeway. So which column? This one or this one? 3.6 or 1.2? 3.6. Okay, we need one in one direction. So this one is 3.2. Okay, so the free flow speed is 3.6. 52.7. Huh? 76. Okay. Next step is also common. Whether you are calculating a level of service or service flow rate or number of lanes, you need factor for every vehicles, FHV. In all cases, you need FHV. Okay, I have 2% trucks and rolling terrain. This example was also for rolling terrain, right? Okay, so EHV is still 3. Okay, I will put PHV as 2%. How much? Okay, so these two steps are common. You have to calculate free flow speed, you have to know it. Okay, and the next step is you need the factor for heavy vehicles. Then, if you are doing operational analysis, then we are going to use this equation. Okay, so I need volume, which is given. I need peak hour factor, which is given. Number of lanes, what? 4 or 2? 2 lanes. Okay, 2. And FHV just calculated 0.96. So VP is the flow rate. How much is the flow rate? Four, 5. Okay, so it becomes what now? Passenger cars per hour per lane. 3000 was vehicles per hour. Now it becomes passenger cars per hour per lane. How? Because you divide by number of lanes, so it's per lane now. Okay, and you also divide by FHV. And we saw in the previous example, when you divide vehicles with FHV, it becomes passenger cars per hour. Okay, so this is now my VP. What are they asking in the question? Calculate what? Level of service, right? Okay, so level of service can be found from here. If I need level of service, I should put what? Density. Density is Flow rate upon speed. Density is flow rate upon speed. Do I have flow rate? Yes. We just calculate flow rate. Do I have speed? Free flow speed. Free flow speed. Then why didn't I write FFS here? Why did I write S here? Yeah. Free flow, it can be free flow speed. It can be, it may not be. Okay. How do you decide? Based upon breakpoint. If you are behind breakpoint, then you have free flow speed. If you are in front of breakpoint, then you have speed which is less. So I need to decide whether I am before breakpoint or after breakpoint. Okay. Breakpoint equation. This one. Okay. Now they are using adjusted free flow speed. Adjusted free flow speed. And this is again capacity adjustment factors. We discuss adjustments. They are for 4 reasons, 4 conditions. Weather, incident, work zone, driver population. Okay. Anything mentioned in the question about weather? Anything mentioned about work zone? Anything mentioned about driver population? No? And anything mentioned about incident? Anything mentioned about traffic? Yes. So, if no conditions are given, that means no adjustment required. If conditions are not given, no adjustment required. So that means what? Free flow speed is same as what you already have. Okay, so whatever you calculated or measured, it will remain as it is, no changes. Okay. Capacity adjustment factor, we just ignore it. Okay, just assume it's not here. Clear? Okay, and what is the breakpoint here? One 188. Okay. Now my VP was 1645, right? 45. And this one is now 188. Okay. So this one is more than VP. Okay. That means what? Speed equals free flow speed. Okay. So now I can calculate density using the free flow speed. But okay, so look at the table. What level of service? D. Clear? Any questions? Now your speed equals to free flow speed, right? Free flow speed is good or bad? Good, right? It's the maximum speed. But D, good or bad? If I give you D, So good or bad? Bad. Okay. So how is this possible that you are going at maximum speed, but your level of service is so low? Okay. It's still in the range. Still in the range. Anyways, or is it? Maybe not. I didn't check. 55, yeah, low. So free flow speed itself is very low. Free flow speed itself is very low. What can be the reasons? Reasons are in the question. Okay, you can see the reasons over here. Lane width, lateral clearance, ram density. Lane width is minimum. 10 feet is the minimum lane width. Lateral clearance, nothing, 0. Ram density, a lot, 5 in 1 mile. 1 mile is around 1.6 kilometers. So in 1.6 kilometers, you have 5 ramps. So after like 300-400 meters or 200-300 meters, you have a ramp. Okay. So the design of the road is the main reason for low level of service. It's not because of traffic. Traffic is 3000 reasonable. Okay. You can still have the maximum speed, but the maximum speed itself, because of the design of the road, is very low. Clear? Okay. In the same example, now we got more information. Now they are saying, in the same example, what will happen if we have a bad weather? Okay, bad weather means we have moderate or medium rain. Then what will happen to the traffic flow? Okay, so we took the freeway from Bahrain, put it somewhere in Malaysia or something. Okay, so what will happen? What things will be affected? What was the first step? Calculate what? Free flow speed, right? Free flow speed has an adjustment factor, right, of weather. So first of all, I will adjust my free flow speed. Okay. Now medium rain, so first row, but my speed is not 55. Okay, it is less. So I will just take the last value. Okay, I just take 0.96. Clear? If it is between two values, I can interpolate, no problem. But it is even less than the minimum, so I will just take the minimum. Okay, 0.96. So SAF is 0.96. So free flow speed how much? Okay, after that, what was the next step? Factor of heavy vehicles. Factor of heavy vehicles has any adjustment? No. Then the next step? No. Before that? BP. BP has any adjustment? No. Okay. So up to here, no change. But then the next one was breakpoint. Now breakpoint equation has the adjustment. So I need adjusted free flow speed, which I already calculated, and I need capacity adjustment factor as well. So capacity adjustment factor for weather, again doing the same thing. First row, I'm less than minimum, so I will take minimum, which is 0.94. Okay, so CF is 0.94. So now you will recalculate the breakpoint. 50 point how much? 6? 7. And then you have to multiply by 0.94 square. How much? 18? Okay, my VP is still the same, 1645. So this value is still more than VP. There is square. 1742. Okay. See, she knows the mistake as well. I used to do it in the exams. I'll solve whatever I want. Okay. So half an hour, complete paper is solved. Then I start looking at my mistakes. And my teachers were mad at me. The whole paper is like this. But then I cancel everything, obviously. Okay. So this means what? The speed equals to free flow speed still. Okay, speed equals to free flow speed. Okay, so I can calculate. Should I calculate density again? No? Yes? Why? Free flow speed is changed. Speed equals to free flow speed, but not the same value. So now it will be something else. How much? 34? 1645 BP 32.14. Does it change level of service? No. Level of service still same. Okay. But what happened? What was the effect of weather? Reduce the free flow speed. Okay. So free flow speed was 52, now it's 50 something. Another thing is it increased the density. Yes. The value of density has increased. It did not go above the threshold, but there is an increase. Okay. So because of the weather, people are going much slower, taking more care with the free flow speed. Okay, and the peak hour, their spacing is now much closer to each other. Yes, they are now closer to each other. Density is more. Okay, so yes, there is an effect on free flow speed. There is an effect on spacing of the drivers, but it does not change the overall traffic condition. Got it? It does not change the overall traffic condition. Drivers are still in the same condition. The flow is still in the same condition. Clear? Any questions? Okay, so tomorrow we will do some more examples. Tomorrow, not Thursday. Okay.